Hi, and welcome to the video on chemistry and proportions. Before we get started, I just want to talk briefly about proportions or ratios. They are super easy and we use them all the time. Whether you use them when you are baking and you want to scale up or scale down a recipe, when you're building something and you don't have the right amount of materials as described in the instructions, or you want to make a different size, you use proportions. So they're a super useful tool. It's important to note that there are different ways to set them up. We're going to look briefly at the first two methods: scalar, which is the method you use when you are doing things mentally; proportion method, which kind of looks like the scalar method, except for when we talk about proportion, we're going to have two fractions, set them equal to each other. And then the second proportion method 2, this method, we're setting up two different fractions than we do in one, but again, we have two fractions, we set them equal to each other. At the end of this video, we're going to focus on proportion method 2, and that's because this method is super helpful when we're doing a technique called dimensional analysis. Now, most of your textbooks and videos that you'll see online in terms of solving the problems that you see here are going to use dimensional analysis, and proportion method 2 helps us with setting up the fractions for dimensional analysis. Okay, scalar method. So this is the sort of method you would do mentally. If you were asked the question, how many eggs are there in 1.25 dozen, you could probably solve that mentally and say that there are 15 eggs in 1.25 dozen. What exactly are you doing mentally? So here I'm just pointing out the information in the problem because we're going to use that to create our find. We know that 1 dozen is equal to 12 eggs, and what we're trying to find is how many eggs in 1.25 dozen. So mentally, what we probably will ask ourselves is, well, what do I need to multiply the 1 by in order to get to 1.25? And that math we can do easily. And the answer to that is 1.25. So 1 times 1.25 gives you 1.25. So then we figure out, well, what do I get when I multiply 12 by 1.25? So I'm going to do the same thing on the other side. 12 times 1.25 gives you 15, and so x equals 15, and that's how you got your answer. Now, although the scalar method is great when we can do things mentally, sometimes we're not sure what we need to multiply this value by, and it's not easy to do. And so in that case, the proportion method is very helpful. Let's look at our first proportion method. The information that we start off with is the same. We know that 1 dozen is equal to 12 eggs, and we're trying to find how many eggs in 1.25 dozen. But in this case, what we're going to do is we're going to take these two equations and turn them into fractions. So we just draw fraction lines underneath both equations, and now we have two equations. One equation where you have 1 dozen over 1.25 dozen, and the other one where you have 12 eggs over x eggs. Notice this is a dozen to dozen and eggs to eggs fraction. Since you have two fractions separated by an equal sign, you can solve using cross multiplication, and we have 1 times x and 12 times 1.25. To isolate our x, we divide both sides by 1, and we get x equals 15. Okay, and so we would get the same answer that we got when we did this mentally using the proportion method. The second proportion method we're going to look at, we are also going to turn these equations into fractions, but we're going to do it differently. So instead of drawing fraction lines underneath these values, what we're going to do is we are going to take our known equation, let's do that one first, and we're going to turn that into its own fraction. So we'll get 1 dozen over 12 eggs. Then we do the same thing with the find. We take that equation and turn that into a fraction, 1.25 dozen over x eggs. And then we can set those two fractions equal to each other. And that makes sense because if 1 dozen has 12 eggs, then we can figure out how many eggs are in 1.25 dozen, because this should just scale up by the same amount. So here are our two fractions set equal to each other. Let's go ahead and solve using cross multiplication. So again, the work looks the same as in method 1. 1 times x equals 12 times 1.25. Divide both sides by 1 to solve for x, and then you would get that x is equal to 15. And so we would say here that there are 15 eggs in 1.25 dozen. All right, for the rest of the problems you see here, we're going to use CFU questions from Unit 5, Day 4 packet. So if you need a moment to get that out, take it out now. All right, for CFU 2A, it asks, a glass of water contains 20 moles of water molecules. How many water molecules does it contain? It's super important with all of these problems that you annotate key information. So in this case, the key information is they give us the moles, which is 20 moles. So moles is equal to 20 moles. And MOL is the unit that we use for moles. Like we would write G for grams, we write MOL for number of moles. And we're trying to find the number of water molecules. So our number of molecules is our question mark, or equal to X. Now, since we're relating moles to the number of things, what we know is that 1 mole is equal to 6.02 times 10 to the 23 things, in this case, the things being molecules. And we're trying to find how many molecules are in 20 moles. So we have our two equations here. We're going to convert these into two separate fractions. Let's take our mole, 1 mole is equal to 6.02 times 10 to the 23, and make that into a fraction. And let's take our find equation, 20 moles equal to X on number of molecules, and turn that into a fraction. And so we have our two separate fractions here. And we can go ahead and set those fractions equal to each other. Now, before we go on, I just want to point out that you notice that in this case, for method number 2, that the units must match for both fractions. So if you have mole in the numerator here, you need to have mole in the numerator of the second fraction. Molecules in the denominator of the first fraction, you need to have molecules in the denominator of the second fraction. All right, so here are our fractions again. We are ready to solve using cross multiplication. And when we do that, we get 1 times x on one side and 20 times 6.02 times 10 to the 23 on the other. To isolate our x, we can divide both sides by 1. And in the end, we get x is equal to 120.4 times 10 to the 23, or 1.204 times 10 to the 25, if we're doing this in scientific notation. It's important to note that if you don't know how to do scientific notation, you should go back to that video, because this may seem confusing otherwise. So that homework assignment on scientific notation is super helpful here. All right, and finishing off this problem, we would say that there are 1.204 times 10 to the 25 water molecules in 20 moles, okay, since we're answering this question. All right, let's look at CFU 2B. In this case, it says the diamond contains 1.38 times 10 to the 24 carbon atoms. How many moles of carbon does it contain? It's always important to start off by annotating. So for this problem, we know the number of atoms is equal to 1.38 times 10 to the 24. And we're trying to find the number of moles. Since we're relating moles to the numbers of things, we know that 1 mole is equal to 6.02 times 10 to the 23 atoms in this case. And we're trying to figure out how many moles would contain 1.38 times 10 to the 24 atoms. So that's our find. Let's take these two equations and turn them into fractions. Okay, notice how for our find equation, before we go on, notice how our find equation actually comes straight from the information in the problem. So we just take those two pieces of information to make our find equation, and then subsequently our find fraction. Okay, we set the two fractions equal to one another, and then we can solve using cross multiplication. So here are our two fractions, and we're going to cross multiply to solve. We get 1 times 1.38 times 10 to the 24 is equal to x times 6.02 times 10 to the 23. And in this case, to isolate x, we're going to divide both sides by 6.02 times 10 to the 23. And that will cross that out on that side, leaving us with x is equal to 0.229 times 10 to the 1, or in a more simple standard way is 2.29. So we say that there are 2.29 moles in 1.38 times 10 to the 24 carbon atoms. A note in terms of your final answer, you may be asking, do I have to change what my final answer looks like? Do I have to put it in scientific or standard notation? I will not be marking off for that, but this is an important skill, so it's great to practice it. If you're not so confident on it in an assessment, and this is the answer that you came up with, you can leave it there, or if you came up with this answer, you could leave it here, it's fine. All right, before proceeding on in the video, it's a good idea to just practice some of the skills that we learned by redoing CFU 2C and 2D. These problems are written here, so if you've already done them, you can do them on a separate sheet of paper. Pause the video now. When you press play again, you will see the answers. Okay, so here are the answers. You can go ahead and check your work. All right, if you have more questions about that, you should check in with me. If you're not sure how you, if you think you've made an error, I would start by trying your calculations over again. And then if not, use the video to help you identify any mistakes that you may have made in your setup or in your math. Okay. Let's go on now to CFU 7A. So now we're in the section where we're dealing with the relationship between moles and the mass of an atom or mass of a molecule. In this question, it asks a piece of copper wire weighs 11 grams. How many moles of copper does it contain? And that should say of, by the way. So we know that the mass is 11 grams and that we're looking for the number of moles. Again, annotation is key here because I'm going to take the piece of information, the two pieces of information from my problem and make that into my find equation. And I know that 1 mole is going to equal to the atomic mass of the atom. Remember the atomic mass, we get this from the periodic table. So in the periodic table, it shows that the atomic mass is 63.55 for copper, and that's what 1 mole of it weighs. So that will be what I know. I'm going to take the know equation and now turn it into a fraction. And do the same thing with the find equation. I turn that into a fraction. All right, so I have my two fractions here. Again, notice that moles are in the numerator of both fractions and grams is in the bottom. It doesn't matter which order you have them in as long as they're consistent. If moles in the numerator in the first, it has to be in the numerator of the second. All right, we can set these two fractions equal to each other, and now we can go ahead and solve using cross multiplication. So here are our two fractions again. We're going to cross multiply to solve. In this case, we have 1 times 11 on one side and x times 63.55 on the other. To solve for x, we're going to divide both sides by 63.55, and then we get x is equal to 0.173 moles. And so our final answer here is that there are 0.173 moles in 11 grams of copper atom. If you have questions on how we get the molar mass or atomic mass for copper, refer to the video on atomic mass and molar mass. All right, last example, we're not going to solve this. This is also from the day 4 packet. This is CFU-B, and it says a container of salt, NaCl, weighs 737 grams. How many moles of NaCl in the container? So what I mean is we're not going to solve this is I'm just going to show you this general setup, but I want to point out to you in this case we have a molecule, and I know that because we have 2 atoms, so sodium and we have chlorine. Since we have more than 1 atom and it's a molecule, we have to calculate its molar mass. And when I do that by adding the atomic weights of sodium and chloride together, and I get this value, 58.44 grams. So you actually have to find this number using the information in the periodic table. You have to calculate it using the information in the periodic table. So if you're not sure how to do that, refer to the video on atomic mass and molar mass. So once I've done that, once I've calculated the molar mass, I know that 1 mole of sodium chloride is equal to 58.44 grams, and I'm trying to find the number of moles in 737 grams. So at this point, everything else is the same. I take my known information, turn it into a fraction, and my find information, turn it into a fraction, and then set those two fractions equal to each other. To solve, I cross multiply, and then I do what I need to do to isolate x. All right, next steps. The next steps at this point will be to do more practice problems, and I recommend you use the Unit 5 Day 3 packet. That was a packet with a bunch of practice problems which we did not solve, but what we did was we identify which equations we're going to use. So find that packet and do practice problems from that packet. Check your answers using the answer key and identify and correct any mistakes. If you feel that you need to, look for more problems to do more practice. I hope you have found this video helpful. Have a quality day.